In our next section, we're going to continue talking about angles with the vertex not at the center of a circle. And in these two examples, our vertex is outside of our circle. So remember, our vertex is the point of our angle that we're looking at. So in example 1, if this is our given information here, we want to figure out what AB is. And we should probably put those points out here. A is right here, and B is right here. And then we also have point C over here. Okay, so if we're looking for the measure of arc AB, that is right here, and it is written on there for us, it is 110. So if we want to figure out what the measure of angle 1 is, we need to use our equation from 11.5, our equation for an angle with a vertex outside our circle is the angle is equal to the arc minus the arc over 2. So if we take our larger arc in this case, which is 250, minus our smaller arc, which is 110, and divide that by 2, we get 140 divided by 2 is 70. So our angle 1 in this case is 70 degrees. In example 2, we are looking for angle 2, and again, that vertex is outside our center, so we are going to use our equation for an angle outside the center. Our angle is going to equal our arc minus our arc divided by 2. In this case, our arc AB, our large arc, is 140, and our second arc is 70. Divide by 2. 140 minus 70 is 70. Divide that by 2, we get 35 degrees. Okay, let's go on to the next examples. Okay, for our example number 3, this is our given information. So you'll want to go ahead and label the points and the angle numbers on your diagram. And then our given information is listed up top. So the first thing I'm going to do with that given information is label it on my diagram. So if AC right here is 80 degrees, I know that CE right here is 60 degrees. I know that EF is 20. And ED is 180. So from D here all the way over to E is 180. Okay, so then the first thing I want to find here is the measure of angle 1. So my angle 1 here, if I look at the vertex of that angle, I know that it is inside my circle, but it is not at the center. So my equation for that angle would be my arc plus my arc over 2. And you can refer back to our chart 8.5 to review what those formulas are. So in this case, my arcs, I have my arc across from angle 1 is 80 degrees, and my arc across from angle 4 goes from D to E, which is 180. So I have 180 plus 80 divided by 2. And sorry, this isn't 180. This is supposed to be 130. So let's change that. 130. I was thinking it looked a little short. 130. And 130 here. Okay, so 130 plus 80, that gives me 210 divided by 2, gives me 105 degrees. So that is my first angle, 105. I can write that in there. 105 is angle 1. So if I know angle 1, I can do vertical angles. Those two angles are straight across from each other. That makes angle 4 also 105. Then if I want to find angle 2, I know that up here, angle 1 and angle 2 are on a straight line. They're going to add to 180. So if I have 180 minus 105, that gives me what's left for angle 2, which is 75 degrees for angle 2. And then once I know it's angle 2, again, I can use my vertical angles to find angle 3, which will also be 75 degrees. So then all I have left is angle 5. And angle 5 is right over here. The vertex of this angle is outside my circle, so I'm going to use my equation from the previous page, which was my arc minus my arc divided by 2. Now in this case, I need to figure out what my arc here, AD, is. But I know the rest of my circle. I have DE is 130, EC is 60, and CA is 180, is just 80. So if I start with 360 degrees in my whole circle, and I take away all those other pieces, I take away DE, take away EC, and I take away AC, I am left with my AD, which is 90 degrees. So AD is 90 here, and I know EF is 20. So I can plug in my arcs, 90 minus 20, divide by 2. 70 divided by 2 is 35. So my angle 5 is 35 degrees.